In the last part of our seminar, we're going to take a look at one more example here that's more of an application problem. And it says the function, and we have three cases here, don't we? Is 3x if x is between 0 and 1. It's 3 if x is between 1 and 1.5. And it's 2 if x is greater than or equal to 1.5. And so what we're going to do is we're going to graph this. We're going to make a table again. I think on this table, I'm going to count by 0.25 at quarters because I see 1.5 as my cutoff point, so I want something a little bit smaller than that. So I'm going to start at 0. I'm going to go 0.25, 0.5, 1, 0.75. Whoops, I can't count, can I? It's 0.75, then 1. 0.75, and then 1. And then I'll go 1.25, 1.5, 1.75, 2, 2.25, 2.5. And that's where my graph goes from there. And let's go a little bit further than 2.5 just to make sure. We'll go 2.75. So we're going to use our rule. Between 0 and 1, I'm going to multiply x by 3. So 0 times 3 is 0. 0.25 times 3 is 0.75. 0.5 times 3 is 1.5. What's 0.75 times 3? I think that's 2.25, but I'm just going to use my calculator just to double check. So if I take 0.75 times 3, yes, it is 2.25. Now, if you're between 1 and 1.5, now notice the underlined for x is at 1. So when I get to 1, I'm going to switch my rule. There is no x here. The answer is just plain old 3. So between 1 and 1.5, you're going to be at 3. So 3, 3 again. Then I get to 1.5, then I'm going to use my other rule. I'm going to take it times 2. I guess I didn't need to go that far because I only had to go to 1.5. So 1.5 times 2, well, that's also 3, isn't it? But 1.75 times 2, what's that? Well, that's 2. 1.75 times 2. Is 3.5. And then 2 times 2 is 4. And I think that's all I need. So what I'm going to do is I'm going to put x in the bottom of my graph, and I need to go up to 2. Well, I think I count by 0.25. So I'm going to count by 0.25s. I'm not going to write in all of them, but I'm going to count by 0.25s. What do I mean by that? Well, here's what I mean. I'm going to start at 0. And that's way too thick, so I want to make it thinner. Then my next one is 0.25, but then I'm going to go 0.5, 0.75, 1. 1.25, 1.5, 1.75, 2. And then 2.25, 2.5. And I didn't go any further than 2. I only went to 2, didn't I? So that's good enough. Then I'm going to go from 0 to 4. So what I'm going to do is I'm also going to count by 0.25s here, I think. So here's 0, 0.25, 0.5, 0.75, 1. Actually, I think I can fit these in here, so I'm going to actually fit them in there. I'm going to say 0.25, 0.5, 0.75, 1.25, 1.5, 1.75, 2, 2.25, 2.5, 2.75, 3, 3.25, 3.5, 3.75, and 4. Now let's plot our points. So when I'm at 0, I'm going to be at 0. When I'm at 0.25, I'm going to be at 0.75. When I'm at 0.5, I'm going to be at 1.5. Make my graph a little bit smaller so I can see my numbers here. When I'm at 0.75, I'm going to be at 2.25. And then when I'm at 1, I'm at 3. When I'm at 1.25, I'm also at 3. When I'm at 1.5, I'm also at 3. And then when I'm at 1.75, I'm up at 3.5. When I'm at 2, I'm at 4. Now let's connect the parts. I'm going to connect the line from 0 to 1. So from 0 to 1, my line looks like that. Then I have a horizontal line from 1 to 1.5, and then I have another line after I'm at 1.5. And then I'm supposed to interpret each part of the graph. Well, it kind of looks like, let me make this a little bit thicker, from 0 to 1, the hiker walked 3 miles per hour. Because that's what the 3x means. Okay? From 1 to 1.5, the hiker rested. They didn't go further, but they didn't turn back either. Then they walked at 2 miles per hour after that. And there we have it.